just like with quadratic equations, we have certain methods to solve quadratic equations, or if we have linear equations, we have certain methods to solve linear equations, or perhaps we have some higher degree polynomial and we can use like synthetic division or guessing and checking. Those are all methods to solve certain types of equations. We are going to have separable differential equations. That's one type of differential equation. So the first question is, what is a separable differential equation? First, I want you to recall that a differential equation is simply an equation that involves a derivative and maybe other variables. And a separable differential equation means that you are able to separate the variables along with their differentials. So use like dx or dy or dt or ds or whatever kinds of variables you have. So let me, and it actually looks like this. If you can write it in this way, then it's a separable differential equation. Now, it doesn't look like it's separable. You might not see that it's separable from writing it like this, but if you can write a function only involving x, or an expression only involving x, times an expression only involving y, then you can actually separate the variables, and this is considered a separable differential equation. Here, I could multiply by, this is actually what we're going to be doing, multiply by the differential dx. We're thinking of it like it's just a fraction, so we have dy equals f of x, some expression involving only x, and maybe numbers, but no y's, and then times some expression only involving y's. So, and then I'd have my dx over here. Well, if I'm trying to separate the x's from the y's, I would divide by g of y. So I get 1 over some function involving, y, and I have my dy equals f of x dx. Now I've separated my variables and my differentials. That's what it means to be a separable differential equation. If you have something like this, dy dx equals f of x plus g of y, or minus g of y, plus or minus g of y, this turns out that won't be separable. So separable differential equations have that form, and we're going to take a look at an example for that. So here I have two differential equations, and I'm telling you ahead of time that the left one is separable and the right one is not separable. We can see if we added stuff over, things would happen and I wouldn't be able to separate, but I'm going to show you. I'm going to try both. You really, unless you get like really comfortable with it, when you're starting out, you really don't know until you try to separate variables. So what I'm going to do is I just take the separable differential equation, I wrote it down, and I'm going to try and separate. I'll add xy to both sides, and what I can do is factor out. I could factor out an x from the right side. I can factor out an x from this, and then I will have my function just involving x times my function just involving y. That's what's going to happen right now. And then I'll do the steps that I had before, where I multiply by the differential dx. And if I do that, I can think of it just as dy on the other side. And the last part is to separate my variables. Well, I want my y's to be over on the dy side, and I want my x's to remain on the dx side, so I would divide both sides by y plus y cubed. So what do I get? I get, the stuff on the left and the stuff on the right. That goes away. And there we have it. We have all the y's and dy's on one side and all the x's and dx's on the other side. That's why it's called a separable differential equation, because we are able to separate the variables. So that's pretty much, I mean, maybe I can't solve this very easily, but this is a separable differential equation. And we'll look at how to solve these in the next video. But right now, we're just seeing what is a separable differential equation. See if it's separable by trying to write it as f of x times g of y, some function of x times some function of y. So I told you that one was separable, and I hopefully showed you. Hopefully you believe me. And then I want to show you that this is not separable. So what I'm going to do is I'll take that, write it down, and then add the 3y over. So I'm just going to start trying to separate. I mean, like right now I can see that I'm going to be writing it as like f of x. I'm going to be writing it like that, where I have f of x plus or minus f of or g of y, something like that. But right now I'm just going to try and separate. So that's what I get there, and then I'm going to multiply by the dx part. Yeah, okay. And here I can't separate. Some people forget the parentheses, so make sure you don't forget the parentheses. I could distribute the dx, then I have a dx and an x. That's great, but I also have a y and a dx attached through multiplication, so that doesn't help me. I can't separate on this one. There's no way to do it. I can't just divide by -3, because then I would, or sorry, -3y, because I would have to divide this by -3y, and then I would have x's and y's mixed up again. So this one, I cannot separate them, so it is not a separable differential equation. That's all. That's the first video, just deciding which ones are separable, which ones are not, and actually how to separate them. So in the next video, we'll learn how to solve a separable differential equation. Goodbye.